Good morning, Alan Sills here, and I want to take a few minutes out. I'm going to put on my instructor hat, my science educator hat, and talk with you a little bit about climate and about weather. And what prompted this was a walk yesterday, and I got some photographs that I'll put up on the site where I'm getting this blog together, this blog post together. A walk the other day, yesterday, that was right after the summer solstice. So I want to talk first about climate. Climate is long-term patterns. Climate is a relatively predictable thing. For example, we know now that it's about the end of June, just past the summer solstice, that first of all, from an astronomical perspective, days are beginning to get shorter. And this is something that's not apparently immediately evident to most people at this time of year. It'll become much more evident in about 3 or 4 weeks that days are getting shorter and nights are getting longer. But it also begins to affect temperatures at some point. And I'll talk about that briefly. Then I'm going to talk a little bit about weather because right now at the end of June, we have an interesting weather pattern moving in. And I'm going to give you a link where you can look at an excellent analysis, a really good analysis that was just put together by AccuWeather. And I want to share that with you. So let's talk first about climate and astronomical patterns. Just past the summer solstice, and I'm going to keep this in fairly simple terms, not to dumb it down, but to make it understandable, that that's the day around June 21st where the sun is highest in the sky at midday throughout much of North America, pretty much from the Tropic of Cancer, 23.5 degrees, all the way north up to the North Pole. So we're talking about the northern hemisphere from the Tropic of Cancer, 23.5 north up. The sun is as high as it's going to be. Now, when I lived in Florida, in West Palm Beach, that meant that at midday, which is depending on where you are in the time zone and the fact that we move the clocks forward an hour for daylight, somewhere around 1:30, maybe as late as 2 o'clock in the afternoon, you would pretty much have to look straight up to what's called the azimuth in order to see the sun. Of course, you shouldn't look at the sun. Or if you look down, you'd have almost no shadow. Now, imagine in your mind's eye traveling north from Florida. The farther north you go at midday, the longer your shadow is going to be. Why? Because the sun is not directly overhead. The sun is on an increasingly opaque angle. It's on a lower and lower angle with respect to the horizon. Now that makes, for lack of a better phrase, and it really is pretty much what it is, the sun is weaker. All right, the sun is weaker at higher latitudes, not higher altitudes. Now I'm up at 8,100 feet and I'm inside today because it's already getting kind of hot out there. We're going to talk about that. But at higher latitudes, the sun is increasingly weaker. Let's put it this way. In Fairbanks, Alaska, you're not going to get sunburned nearly as quickly as in Miami, Florida. Because in Miami, Florida, at midday, the sun is nearly directly overhead, and at Fairbanks, Alaska, it's on an angle. Now, during June and July, the heat is building up, and there's going to be a heat wave that, according to the weather forecast, we'll talk about that in a minute. During June and July, the heat is building up. What's happening is the oceans, which remember, they're 70% of the planet's surface, are gradually warming up as we get into summer. Having grown up in New Jersey, I can tell you that the warmest ocean, the warmest seawater temperatures are usually observed in late August and early September. That's when the oceans reach their peak. And coincidentally, not coincidentally really, that's close to when the seasonal peaks occur on the landmass. The landmass right now, even here in Colorado, where I'm hundreds of miles inland, is being impacted by the ocean, specifically the Pacific Ocean, which is still quite chilly in June. So we're not as hot now at the end of June as we can be for the season. That occurs about 4 weeks after the solstice. So what I want you to take home is around July 21 is the maximum temperature that will be observed across most of the United States. And that's really who I'm talking to right now. And Canada. Most of the US and Canada will see their peak temperatures around July 21st. So what we have right now are two competing effects. The days are beginning to get shorter. The sun, which was at a peak on June 21st, ever so slightly begins to come down in the sky. Here's a way to think about it. midday occurred on the North Pole on June 21st, and the sun is beginning to move towards setting, which will happen on the North Pole on September 21st. Now that's significant, and we'll talk about why in a moment. So, as the sun begins to get lower and lower, eventually there will be less incoming solar radiation energy from the sun and more outgoing energy at night, so the temperatures begin to start cooling off across the landmass of North America. Again, that happens after approximately July 21st. So in other words, in an area where I am in 8,100 feet in the mountains in Colorado, very quickly in August, it becomes quite obvious that we're making a switch from summer to autumn. So it begins to cool off noticeably in August. Now, of course, if you're closer to the ocean or if you're farther south, that noticeable cool down is delayed. Now, remember, the oceans are still warming up. They warm up all the way into August. So if you're close to the ocean, you're probably going to experience a slower cool down. All right, to the point where in Florida, that cool down is not really noticed until mid to late November. That's about when that cool down really happens. However, farther north, I mentioned a moment ago, the sun will set at the North Pole on September 21st. That means during August, the sun is getting very, very, very close to the horizon. All right, I'll bring that down here. The sun, which was a little higher, is getting very close to the horizon. So what does that mean? It means the air begins to cool off. So over the North Pole, over northern Canada, Siberia, over northern Alaska, a pool of cold air or quite cool air begins to build up during August, all right, particularly late August. So as you move into September and October, that cool air will begin to slide southward across Canada and into the United States. And for those of you in the northern half of the US, I know growing up in New Jersey, we'd experience our first cold front passage, big time cold front passage, usually around or right after Labor Day, early September. And it would mark the end of days in the 80s and 90s and the beginning of days that were struggling to reach 70 degrees with overnight lows in the upper 40s. Very different from what we had during August. Here in the Rocky Mountains where I am, that will begin to happen probably a week or 2 or 3 weeks earlier. Middle of August, late August is when it'll be pretty apparent that those nights are getting longer and colder, and it's enhanced by that cool air beginning to slide southward from the North Pole across North America. So even though we're at late June right now, my mind is thinking that, okay, we're at late June and the landmass is still heating up, but that sun angle is getting lower and lower ever so slightly right now and more pronounced in July. And that means the pool of cold air will begin to build up way up north, first in August, and then start sliding southward in late August and September across the United States and Canada. That's the overall long-term pattern. Very predictable, very anticipated, and it doesn't vary much except for, exactly what day is this pool of cold air going to move southward. Now, while we have heating occurring over the continent, we also have weather patterns that occur across the United States and Canada. You're going to see access to a video in a minute. I'm going to link you there below this video to where you can see what the current pattern looks like. I'm not going to repeat what the forecaster says or the meteorologist says that does really an excellent job in this analysis. All I'm going to tell you is this. Weather is short-term patterns. At the moment, and maybe for the whole summer, I don't know, we're shaping up with a pattern that is going to produce very hot, very dry weather across the West. Now that's a problem. Where I am here, we have tinder, dry forests. We have a lot of dead trees because of a beetle kill. There's a beetle that killed a lot of pine trees, and they're all over the place. So the hotter it gets and the drier it gets, the more of a risk there is of forest fire. For those of you that follow the news, Colorado's already had some serious problems with forest fires. And as I've said to the locals here, it's only June. What that means is forest fire season is really towards the end of the summer. That's when it gets worse, and it's conditions like this that will enhance that. Now, while we're baking out west here, and again, it's got nothing to do with long-term global warming or any kind of thing like that. This is just a heat wave. It's that simple. In the east, you have what is called a trough. The meteorologist will explain what that is when you watch the AccuWeather video. That's going to produce very tropical conditions, very humid, afternoon thunderstorms, or maybe thunderstorms off and on all day, and a persistent southwesterly flow. Now, in a perverse way, that also can create something called upwelling along the immediate shoreline, which means while the air temperatures are very high, while the humidity is extremely high, and you want to go for a dip in the ocean, the upwelling could cause sea surface temperatures to dive below normal. So late June in New Jersey, normal is probably about the mid 60s. Diving below normal means mid to upper 50s. Not fun. Not really a comfortable seawater temperature to jump in on, but that's your call. I know from, again, growing up in New Jersey, July 4th weekend is a great time to go to the beach and, down the shore, as we said, and enjoy a dip in the ocean. But it's much more fun when the water is closer to 70 or a little over. And I know those of you that are thinking about 70, if you're from the southern United States and you're used to 85 or 90-degree pools, you're thinking I'm nuts. But I'm telling you, it's great. It's very refreshing. If the water is much below 70, though, you don't want to really go in. It's probably not that great for you, especially if it's below 60, which it might be, at least for the first few days coming up into next week, which is approaching the July 4th weekend, July 4th being on Thursday. So anyway, I wanted to do this quick lesson. I hope this is of value to you. Days are going to keep getting shorter now until right around Christmas. It'll be the winter solstice. And that'll be December 21, give or take a day. And again, just like with a seasonal lag from about June 21 when the sun peaks to July 21 when the temperature peaks, we also have a seasonal lag in the winter. The sun reaches its minimum energy in North America right around December 21. And the minimum temperatures, however, are not reached until about January 21. And that's again because the sea surface temperatures keep cooling off for another few weeks. So anyway, hopefully that sheds some light on things. And well, anyway, I had fun. I hope you learned something. Contact me if you have any thoughts or questions or give me some feedback here. All right, you take care.